I promised you a quick video on schedule, and I'm just right on the heels of the last one where we got through all the interrupt stuff and finding out that it finally gets to a schedule call. So let's quickly go to that. But before I do, I've had two other requests for videos. One is on Ethereum blockchain technology. I think it has something to do with cryptocurrency. Not sure, but this channel is for me to learn first and for you to follow along afterwards. So that's what I'm going to do. The other one is show a Python project. For those of you that have just the basic essentials of Python, we're going to set up a nice project that does something substantial. So what means I got to pull out my Python tools and get busy with that. But that'll be fun. I love coding. So let's get going on with the topic at hand, which is scheduling a task at last. We'll start where we left off. Here is the function called exit to user mode loop. So notice the thing user mode. So we're actually getting out of the interrupt and to user mode. Then we say TI work and we check to see if TI work yields something more than zero. And if that's the case, then we will call schedule. Now, keeping it quick, I'm not going to linger on this. I'm going to go straight to schedule. Here's schedule. Schedule says, let's see, let's get down to the nitty gritty. That says something is, checks to see if something is not running and schedule submit work. And then here's the key is underscore underscore schedule loop. And using my handy dandy search tool, we will find out where schedule loop occurs. Here I've found schedule loop. And if we go down in here, we find out that it does some different things. But the key one is, let's get to where something actually happens, is underscore underscore schedule. Let's find out where underscore underscore schedule is. And we arrive at underscore underscore schedule. Let's find out if something happens. One thing I like to notice here is that I have task struct, and there's a previous task struct and a next task struct. That means that's the one we're going to if we decide to make that switch. Okay, we're doing a local IRQ disable, doing some other stuff. Let's find out something that's very interesting. I don't know. I don't see anything interesting yet. Let's find out. Let's find out. Keep going down here. This is important because we don't want to make a switch unless it's exactly what should be happening. Let's see if I'm looking for a context switch that somewhere along the way should happen. Let's see if that occurs. Boy, we're making a lot of decisions here. And we're at the end of the schedule, so I must have missed something. No, I didn't. Here it is. Context switch. Switch. How about context switch? So our next journey will be to context switch. I doubt if it's in this file, but I'm going to do a quick check of it to see if that's true. Context switch is in here. That's nice. Don't have to go to different files. Okay, context switch says prepare for task switch. Architecture specific, start context switch. And let's see, are we done yet? Are we done yet? Are we there yet? Are we there yet? What's the biggest thing? Okay, switch to. Switch to is very important. It goes into assembly language, but I said this video is going to be short, so we won't go into the assembly language. So it says switch to, which means that we're replacing and restoring registers from these different things, and then we do finish task switch. And we're passing it the previous one. Let's see what that does. If we don't get to it quickly, I'll just close this out and say that's the way it works. That's the way it works. Let's find out if there is another definition of that in this file. Finish task switch. Let's see what goes on here. Remember, we finished the task switch and then return. That means we'll return right back to where schedule originally called. It's getting everything ready, switching stuff around, some last minute stuff, talking about memory because that's important. And then we return the run queue. And that's about all we need to talk about because that means that it returns to a task just the same as if it was the current task, but now it returns to another task and all the different stuff, the memory locations and all that stuff is switched around so we can resume this new task. There you have it. After multiple videos and deep dive details, we finally found that. So happy days, and my next video is not going to be about Linux scheduling. How about that? We'll do some other software topics and see if the two subscribers that suggested a couple things enjoy those.